Hey guys, welcome to another installment in my data structures tutorials. Last time we went over a few tutorials explaining on how to implement and what a singly linked list was. This time around, we're gonna go forward and check out stacks and what they are. So, a stack is a linear data structure that can be accessed from one end only. It is usually called or referred to as a LIFO structure, which it's a name that describes what a stack is. So LIFO stands for last in, first out. And how are they useful? Well, they're very useful in many ways. Um, when your data has to be stored and retrieved in reverse order, the compiler works like this. Your memory has a stack with registers that do these functions as well. And when we get to uh, recursive functions, I'll explain in more detail on how it works in your memory. But yeah, the compiler works like this, and it checks your syntax. Um, it checks every function, all your code, every code block, and it checks to make sure they have matching delimiters. And I'll show you what I mean by that. So this is a stack. It's a little container, and whenever you whenever the compiler reads your code, it puts certain things in here, like brackets, braces, curly braces, etc. And whenever it pops stuff off of here, it makes sure that each of these elements has its the other part of it, which is the closing part. So these have to match. And if it doesn't, then you have a syntax error and you cannot compile. So that's how that works. It can also be used for, like in video games, backtracking on a path. If you're doing artificial intelligence, let's say you have a starting node here, then you have another node, and another node. And you run your calculations to check what the best path would be to get to this point, and you traverse through your path, and every time you hit a node, you would put it in a stack. So the first one would be start, then this guy right here be 1, then 2 would be here, and then end or whatever, or E for end. Okay, you would put it in a stack like this. So when he's done over here doing whatever he needs to do, and you want him to go back to the way he came from, to the way he started, you might want to use your stack for this instead of having to recalculate the path, because doing that can take some memory resources from you, and depending on how big it is. So this one will, when you pop it off, it's like, okay, you can start at the end node, which is this guy, then go to the second one, then go to the first one, and then you're at the start. So that's how that would work. Another way it can be used, a stack, it's with the undo button. It stores every stroke, every character you ever put in, and yeah, it's pretty useful. That's how that would work. A stack can be implemented as an array, and there's obvious problems with this because you have a set number of elements you can store, and um, whenever your stack is full and you try to put stuff in it, there's a term we use called Stack Overflow, and that is just it's when you don't have any more space and you're trying to jam more stuff into your structure. Stack in this case. The way I like to do it and the way I'm going to show you how to do it is through a singly linked list. So what makes a stack a stack? A stack has to have these 2 or 3 functions depending on how you want to implement this. The first one is going to be the push function, which stores in, it puts whatever data you want to store in your stack at the top. So let's say we want to push 10. We would store it right there. And if we want to push 5, it would go here. And then push 6, it would go all the way on the top. Now, we can only look at the topmost element. We cannot look at the other below ones. That's why it is called a LIFO structure. Last in, first out. The queue is backwards, but we'll talk about that in a future tutorial. So the next function that we want to look at that makes a stack is a pop. What pop does is it takes this little guy and it just chucks it away. Like, get the out of here. So if we do pop 6, I mean, just pop, you don't have to put anything in it. It removes it. Then pop again, removes that until you get to the last one and it's gone. The other function that I like to implement is called a peek function. And this one returns data. So when you put stuff in a stack, in order for you to process this data without removing it is via the peek function. What it does, it just looks at the topmost data you have in your stack and it returns it. It doesn't remove it from the stack. It just returns the stack, the data. So you can either add it or subtract it or just check it like the compiler would do or whatever. This is another way actually to use a stack is if you have super big long numbers, like huge numbers, and you want to do arithmetic with it, you would have a lot of little stacks and store, like let's say you add one number, you get a big number, then you would add part of that number into another stack and then part of the other number into the other stack, and then you would just add those that way. Um, so yes, some people like to implement the pop as peak and pop at the same time, which I don't really like to do that because I don't know. I think this is much better since peak is only supposed to look at the first element and not remove it. Some other helper functions are clear, and which just clears the stack, and the other one is it's a function that checks to see if the stack is empty or not, and it returns a boolean, true or false. Okay, so I hope you guys learned something here. I'm gonna make this short, and then I will continue on to the implementation of the stack in the next tutorial. Thank you for watching. If you have any comments, concerns, please don't forget to comment below. If you liked it and you want to see more, please subscribe. Thank you very much for watching, and hope you guys have a good day.